Well, greetings there, ninth graders. This is Mr. Rogers, and this is a quick video that I've prepared to kind of talk us through the sedimentary rock rules now that you've had a chance to see the answers to the lab, to see now what are the rules that sedimentary rocks follow, and then some key vocabulary that is common for them as well. So I'm going to hit the present button here, and we are going to get rocking and rolling with it. Go. All right, so if we start with sedimentary rock rules, there are 5 of them, and I'm wondering how many of them were fresh in your mind from the lab here. So initially we said that sedimentary rocks are just rocks made from other rocks, but now I think we can expand on that a little bit. Sedimentary rocks are indeed leftovers. They're made up of fragments of other rocks. They're made up of sediments. So that's the first rule. The second rule is that sedimentary rocks form in watery conditions. So water needs to be present, and what that does is that creates situations where sediments can get weathered and broken down into smaller pieces. They get eroded, which means they get carried away to someplace else, and then deposited. And that leads directly into the third sedimentary rule, which is that sediments get glued together by minerals that were dissolved in the water in between those pore spaces. So rule number 4 then, when the water evaporates, the minerals are left behind, because remember, water always leaves a mess when it goes away, when it evaporates. So anything dissolved in the water evaporates and leaves behind the minerals. And of course, water is great at dissolving things, so that's why that happens. And then, of course, the 5th rule of sedimentary rocks, which is a little bit larger there near the bottom of the screen, is the size of the pebbles, telling you a bit about how they form. So large pebbles are generated or show that there was fast-moving water, which generally is shallower water. And so you can't carry large pebbles unless the water is moving fast. And when you see large pebbles in the rocks, then that means that was the point when the water slowed down just enough for those large pebbles to drop. So it was moving fast enough to bring them to that location and then finally deposit them there. So large pebbles generally means that the water was moving fast and that it wasn't very deep at that point. Now, when you see smaller sediments, the smaller the sediments, the slower the water was moving, and generally the deeper the waters would be. Because, of course, deeper ocean waters, for example, move at a much slower pace than like a river, because, of course, with all that huge volume of water, you just simply can't move the water and the sediments that fast. So the size of the sediments, kind of like with igneous rocks and the size of the crystals, here the size of the sediments can tell you a tremendous amount about the conditions. And so at this point, if you need to pause the video so that you can finish writing these 5 things down, that's cool. Go ahead and do that. And then we'll continue on after you hit the play button again. All right, so at this point, let's go ahead and talk about some of the vocabulary words that go along with the sedimentary rocks. There's one last piece I want to really emphasize. So I'm going to bring it over to this part here. And again, I have this section here in the notes because it's so very important. In the past, when we've done the Unit 2 assessment, one thing that my prior 9th grade students have sometimes missed is this really important key fundamental piece: the conditions you need to make sedimentary rocks. I suspect you might even be able to say them out loud. If I were in the room, I'd be pulling popsicle sticks right now and asking you guys to tell me before I reveal it. But let's go ahead and reveal it. In order to make sediments, you need some sort of surface water involved in this process. You need sediments for sedimentary rocks, and so therefore you need surface water. You need it to get in there and mechanically weather and break rocks apart. You need it to transport them to different locations, and then you need the water to deposit them. So that's a key condition. The other condition you see here in slightly darker gold color is that you need to glue the sediments, and that can only happen deep underground. The conditions you need to actually evaporate the water and leave behind the minerals to glue the sediments together, that requires a fair amount of heat and pressure. And of course, the more you bury sediments on top of other sediments, the more pressure that they are going through. And of course, the further down you push those into the earth, the warmer the temperatures get. Now, not warm enough to make them igneous. So we're not talking about super hot conditions like we were with igneous rocks, but definitely several hundred degrees Celsius. So above the boiling point, that can make the water then evaporate very quickly, and then it leaves behind the minerals. So those are the conditions you need. You need surface water initially to make the sediments, but then you need them to get buried deeper into the ground, and then for that water to evaporate, and the pressure therefore then can kind of help and evaporate the water, leave behind the minerals, create that glue, hold the sediments together. Just like you see in this animated GIF here on the right. Now, this this blade of grass, it's not deep underground, but you get the sense here. The water evaporates and leaves behind that little residue, that bit of mineral that was dissolved in there. Water is great at doing that. It's an amazing dissolving agent. It's the universal solvent. So it almost always has something dissolved in it. And so therefore, when water leaves and evaporates, it's always going to leave something behind. And so that's a key driving factor for sedimentary rocks. So at this point, I've yabbered quite a bit. So you may not need to pause the video because folks might have had enough time, you all might have had enough time to write this down. But if you need to pause me right now, you can, and then we'll move on to the vocab words. All right, so let's move on. We've got 5 vocabulary words that relate to sedimentary rocks, just like we did with igneous rocks. We had 5 words there. The first 2 words refer to types of sedimentary rocks. Okay, so if we look at this first one, these sedimentary rocks are called clastic sedimentary rocks. It almost looks like the word says classic, you know, like an old classic thing. And maybe you think of it that way. I don't know. Maybe that makes it more clear for you. But clastic sedimentary rocks. Clastic refers to the sediments, the pebbles in there. Clastic sedimentary rocks are rocks that form from sediments being eroded, transported, deposited, and glued together by other minerals. And I like the picture down below here. It's a nice, I don't know, metaphor, analogy. I'm not sure which the right word is for it, but it represents how clastic sedimentary rocks work. So this is pretty close to being Rice Krispie treats. Looks like they might have used a slightly different cereal. But the idea here is that the cereal would be the clasts or the sediments, the particles. The marshmallows would be the glue that holds it all together. That would be the minerals that were in the water that were dissolved, and then the water evaporated, leaving behind the glue. In this case, this would be the marshmallow. And so together, that creates this clastic sedimentary rock structure. So normally when I think of clastic sedimentary rocks, I think of all of the rocks that you were looking at in the lab yesterday, you know, so sand, stones, and other rocks that are just made out of sediments. And you might even be scratching your head at this point saying, is there any other kind of sedimentary rock? And that's a good question. There is actually a second kind of sedimentary rock, and you might have noticed it in the lab. Sometimes you encountered organic sedimentary rocks. So they're also made out of sediments, but they have this organic component. Organic here is referring to life. So these are sedimentary rocks that are formed mostly by dead organic material. So the coal, for example, is made out of dead plant material. So that's an organic sedimentary rock. Some of the rocks that are filled with fossils, even to the point where you might have more fossils than you have sediments, those are definitely organic sedimentary rocks. And so that's the second kind of sedimentary rock that you can have. Now, if I'm going too fast and I'm about to move on here, you can pause the video and let everyone catch up before we move on to the final 3 vocab words. All right, so now we're moving on to the final 3. The final 3 words are not about rock types. They're more about the processes involved, sedimentary processes. So these words can sometimes get confusing, especially because they kind of have different meanings in everyday language, but in the scientific sense and the geologic sense, they're more precise. And you'll see what I mean here in just a second. So the first word here that I'd like you to write down, or actually technically the third word I'd like you to write down, is weathering. So weathering is the word we use to describe either the physical destruction or the chemical destruction of rocks into sediments. That lab we did last week, the rock, paper, scissors, water lab, that was all about weathering. Again, nothing happens by random chance in these units. Everything has a purpose. It all ties together, or like pieces of a jigsaw puzzle. So if you think back to the rock tumbling, if you think back to the chemical weathering and the reactions when we put acid on a few of those rocks and we saw them bubble and fizz, or they made a smell, all of those, oh, and the freezing of the water too, and the expanding and breaking of rocks, all of that is physical weathering or chemical weathering. So that's the word we use to talk about the destruction of rocks into sediments. But there's another word that's used for the movement of those sediments. And here's where you might feel a little confused, because oftentimes we use this word erosion when really we mean weathering. When we talk about rocks eroding, oftentimes in our minds we're thinking about them breaking down and turning into sediments. But technically speaking, erosion is not the breaking down, it's the transportation of sediments from one location to some other location. So erosion is, weathering creates the mess. Erosion gets rid of the mess. It cleans it up. It moves it somewhere else. All right. So erosion then is, pardon me, is our fourth word. We have one final vocab word that we need to write down. So again, if I'm going too fast, you can pause me, but otherwise we're going to move on to the final vocab word. And the final vocab word is deposition. It's kind of the end stage or the last stage of this process. If we weather rocks into sediments, we break them down, and then we erode them and move them to some new location, well, then they got to get dumped somewhere. They got to get deposited, and that's what deposition means. And so deposition is not a new word. Erosion and deposition are words that we talked about in our last unit as well with rivers. And it's the exact same meaning here. So if it made sense to you in that previous unit, just apply that same logic here. Deposition means to deposit. And so deposition would be the accumulation, or better yet, the dropping off of sediments at a new location. And these are all key processes in creating sedimentary rocks. You got to make the sediments, you got to transport them, you got to deposit them. And after the deposition, that's when all the gluing happens, and then they finally become sedimentary rocks. So those are your 5 vocab words, the technical jargon, the professional language that geologists would use. And so when we get to that next process where you are rocking the vocab, then that will be available for you to be able to work on those 5 words and make some sense out of them. And before we sign off with the video, I want you to take notice of this interesting feature. You can see this picture here. Clearly, it looks like it's sedimentary rocks, which of course it is. The really cool part about this photograph is this is a picture taken by a machine, a roving robot on the planet Mars. And so here you can see sedimentary rocks that have formed on another planet, which, if you take this, what you know about rocks now, and apply it, that would be some pretty strong evidence that water flowed on Mars to weather the rocks, to erode them and transport them to some other location, deposit them, and then that water, that Martian water, would evaporate and leave Martian minerals behind in between the sand grains to glue these sedimentary rocks together. So it's kind of cool to see the same processes happening on the Earth, happening on another planet, and then the cool part, the extra bonus part, the stretch goal here, is that you can then use it to prove that there was water flowing on Mars at some point in the past. All right, so that would be the conclusion of this portion of the video. We're going to move on to the next activity, and wish you guys all the best luck here as you move into the next activity.